The James Webb Space Telescope, likewise known as Webb or JWST, is a scientific pioneer that has uncovered astonishing insights concerning stars, planets, galaxies, and other intriguing cosmic peculiarities, as well as setting new standards for scientific fervor. Webb is hailed as the respected Hubble Space Telescope's replacement. People from one side of the planet to the other are exchanging photographs or utilizing crude information to make new bits of knowledge. 1 year has passed since the impressive James Webb Space Telescope uncovered its first-ever noteworthy picture of the universe, stunning stargazers all over the world with its exceptional detail. However, its latest finding is a frightening image of the universe that we have never seen before. What has been found up to this point by the James Webb Space Telescope? Is it suggesting more conversation starters than it deals with? Researchers, join us as we investigate how the James Webb Space Telescope captures the most alarming picture of all time found in history. The successor to the Hubble telescope uncovered new data about star development, universe consolidates, and the early universe just 1 month after the starting photographs were delivered. The pictures were stunning, revealing the universe in depth. From that point forward, the number of discoveries has soared, furnishing researchers with an immense data goldmine. James Webb Space Telescope's observations of enormous tarantulas, record-breaking space smoke stars, nearby cosmic explosion exploblasts, and other fantastic divine objects have been documented. This satellite observatory's cutting-edge technology allows us to peer farther into space than before, revealing previously unknown insights about the universe. Another time in space science has unfolded thanks to the photographs, which can be so detailed. As a method for recognizing the first year of the James Webb Space Telescope's operation, NASA released a picture that shows a minuscule star-forming region in the Linnea-Yukiko cloud complex. The picture shows planes ejecting from infant stars as grandiose residue billows of different colors. Impact subatomic hydrogen makes up the red residue, and the presence of a circumstellar circle stirs up misgivings about a few stars, suggesting the possibility of planet development. In the distant past, the picture might show astronomical pandemonium. However, according to NASA, this heavenly nursery is small and quiet compared to others. Moreover, many of the young stars in this area are about the size of our Sun or even much smaller, making it the closest star-forming region to Earth. This image was captured by the first camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures grandiose pictures in 2 specific infrared ranges simultaneously. Besides, the Space Telescope has worked on our insight into exoplanets or universes that circle stars other than our Sun. James Webb is particularly great at taking a gander at enormous V-cosmic systems. The satellite observatory found its first exoplanet, LHS 475b, toward the start of 2023. The planet is 41 light-years distant and has a measurement similar to Earth, according to NASA. James Webb is the sole functional telescope capable of classifying the atmosphere of Earth-sized exoplanets. After that, the James Webb Telescope found evidence of long-gone cosmic systems that, from a theoretical outlook, shouldn't have existed. Eva Swinburne College and his worldwide galactic group have seen 6 tremendous old worlds called stanza breakers. They have the potential to completely alter the way we ponder space. These enormous systems might have appeared between 500 to 700 million years after the Big Bang, according to the researchers' results. Recently, the telescope's infrared sensors detected them through the use of these instruments, allowing us to look back in time around 13.5 billion years when stars and systems were much older. The huge tremendousness of the universe breakers has left researchers baffled. Cosmic systems in the early universe should have been 10 to 100 times less massive than that. Their calculations demonstrate that these 6 objects might be billions of times heavier than our Sun. The sum of all the stars in one world may be 100 billion times heavier than our Sun. Does the possibility of attempting to grasp something so monstrous make you feel uncomfortable? Although most of the worlds during this period are somewhat minuscule and only expanding very slightly, some beasts reach adulthood much more rapidly than others. It is clear what would cause this or whether the way that it would work. Penn State College cosmology and astronomy assistant professor and study co-author Joel Lader expressed his wonder at the discovery of another class of objects formed at the Big Bang. The discovery that the development of tremendous worlds started at the very beginning of the universe's history challenges many of our previously held beliefs about the state of science. It seems our discovery is so unusual that it presents challenges to the scientific community. It throws into doubt the entire scenario of how worlds formed in the early universe. Way more massive than anyone expected, describes the things. All systems in the reach are considered children since they are still in the process of development. However, universes that are essentially as old as our own have been found in the early universe, which was previously limited to its beginning spectrometry. What separates light into its part frequencies to enable more precise distance measurements is still needed to validate the results, which have researchers scratching their heads. There are only a handful of recently discovered objects for which distance and mass have been verified. Assuming that the data is accurate, galaxy creation had to have been considerably more efficient and rapid than what is currently suspected. The fact that spectra verified our norm working systems-based deductions from the visuals is promising. For a long time, scientists have tried to interpret big history. However, a single piece of apparatus might hold the key. Observations of reality have long piqued the interest of scientists, so it isn't business as usual that conflicting facts presented by telescopes could lead to a lack of clarity. Currently, cosmologist Dr. Katie Mack has chosen to offer her insights into the matter to figure out how this could be happening. She drew out the fact that the JWST has been providing evidence of galaxies that appear to have originated or evolved much earlier than what scientists had expected from their models. Don't worry, though, as Mack pointed out, the telescope is capturing images of galaxies more than 13 billion light-years away, and they are somewhat blurry. It seems like there hasn't even been enough time since the Big Bang for these huge galaxies to have formed. By the dates that astronomers have been getting from the telescope, many in the field are concerned. On different theories, including dark matter and the Big Bang, however, we should go further into the evidence to find out for sure. The telescope captures stunning views of close nebulae but fluffy little dots when it comes to faraway galaxies. The reason is that different colors are affected by different parts of the light spectrum. The Webb telescope can detect light from a source in two different ways. It may use a spectrum by fanning out the light with a spectrograph, which works a bit like a crystal and looking at the brightness of each color, or it can use filters that block everything except a select range of variations. They can then calculate the redshift of the universe by comparing this data with spectra predicted for universes with similar qualities. What this redshift tells us is the exact moment in big history that we are seeing. It just so happens many galaxies have an abundance of stars or stars that were too young when they would have lived by comparisons of model spectra. There are a number of potential explanations for this. The photometric readings could have been off due to issues with the telescope's calibration. On the other hand, they might have been observing a cluster of galaxies that isn't representative of the norm or extremely small patches of the sky. Another possible explanation is that galaxy range models are designed for closer galaxies, which don't work well with galaxies farther away. On the other hand, astronomers would face the thrilling possibility of having to completely rethink big evolution if those galaxies are indeed incredibly large and earlier estimates were incorrect. But it's not the only area where scientists have fallen short. Despite technological advancement, planets that are too massive to exist have researchers highly puzzled, and none more so than the finding of a planet that is considered too massive for itself. This has prompted a reassessment of our system understanding of planet formation and planetary system architecture, as well as the models developed by astronomers in the aftermath. A planet that is 8 times as massive as Earth has been considered, according to research out of Penn State. Legend has it that this planet is in a planetary system around the ultracool star LHS 354, a star that is 3 times less massive than our Sun. Before recently seeing it for themselves, scientists didn't actually believe that such a situation was feasible. The littlest and coolest stars, ultracool bantams, are actually barely familiar to us. This finding demonstrates it's significantly more. A planet of this mass circling a star with such low mass challenges our assumptions. These stars might have started in gigantic holes and residue mists. Planets might emerge from the gas and dust that remain in the plate of material around the infant star. Later, it isn't guessed that the planet-shaping circle encompassing the low M star LHS 354 contains sufficient solid mass to create this planet. However, it exists. Consequently, we should now rethink our speculations regarding planetary development. A good relationship would be to contrast the stars with a pit fire. In order to maintain your internal heat level, you should get closer to the fire as its temperature diminishes. Planets that need to be hot enough to support liquid water should be closer to stars with lower temperatures. If a planet is in a sufficiently tight circle around an ultracool star, we can see the pull of the planet on the star's light or spectra, which causes a little change in the star's variety. Then again, when stars look up very high. Another stunning picture of the ice giant Uranus, featuring all essentially its dusty rings, which had previously been challenging to photograph, has been snapped by the James Webb Space Telescope. For the fainter rings, which have only been seen by the Explorer 2 and WMK Observatory on government rocket hitherto, the image is a stunning exhibition of the telescope's awareness. Uranus, which is 1.12 billion miles from the Sun, has 13 recognized rings, 11 of which are displayed in the stunning new picture from the Webb Space Telescope. As opposed to Saturn's flat rings, this planet's peculiar side slant makes its rings seem upward. The two outer rings were not identified until the 1986 flyby of the Explorer 2 space apparatus, since their dusty makeup made them not so apparent but more challenging to photograph. The 9 significant rings were definitely known about before then. In 2007, photographs captured by the NASA Hubble Space Telescope revealed 2 more fainter outer rings that are not apparent in the Webb photos. Webb can potentially discover them, as indicated by researchers. A planet's ring system provides valuable information regarding the planet's origin and formation. Uranus is an incredibly unconventional globe with its skewed circle and absence of internal heat. Therefore, any information regarding its past would be highly prized. The curious atmospheric makeup of the gigantic gas-based planet Uranus is something that researchers are hoping the telescope can reveal insight into, since no other telescope of this scale has ever been able to see infrared light. The JWST allows us to look at Neptune and Uranus through a sacred novel lens. Telescopes that use visible light, such as Hubble, can't notice infrared frequencies. But infrared imaging can reveal previously unseen depths and features. Also, an exceptional film of a star approaching passing has been obtained by the James Webb Space Telescope. With JWST late 2021 observation, the fading star picture is among the first immaculately recorded events of its kind. The colossal dying star Wolf-Rayet 14 was captured on film by the telescope's infrared lens as it catapulted gas and dust into space. It is believed that this heavenly event is happening 15,000 light-years from our planet. Not sure what it means, but it's around 58 trillion miles away. The image, which was provided solely by NASA, shows the bright purple leftover of the star's outer layer, which was previously a thin cloak of dust and gas, making the star flare. This stunning picture is an enhancement for the one that the Hubble Space Telescope captured a few years ago in 2015. Before the JWST was sent off, the star undergoing significant change was recorded by the Hubble Space Telescope. It appeared more like a bursting ball, but because our technology could not capture the finer details, the destruction caused by Wolf-Rayet 14 is now clearly apparent. It is believed that the burned star, which is located in the constellation Sagittarius, is 3 times bigger than our Sun. Plus, it has expelled an adequate amount of gas and dust to cover at least 10 suns for the present. According to NASA, a star is in the center of this stunning new picture. For the beyond 15,000 years, that star's light has been advancing across the universe. It will require 15,000 light-years for it to reach the telescope's detectors. What appears to be dust around the middle star is actually dust because of this. When a star dies, it releases its outer layers and material into space, as seen in the illustration. Planets will form from this dust as it fans out into space. Actually, this is how we arrived at this point. Experts believe that a star in the process of shedding material is about to explode, a phenomenon often known as going supernova. Although the demise of Wolf-Rayet 14 will be invisible to the human eye, 5 planets will be visible from Earth. Surprisingly, a real monster in space had its look captured by the James Webb Telescope. The spectral entity was seen by the JWST as it hid in space. Actually, it's a galaxy that produces many new stars every year, not some massive extraterrestrial. The galaxy, which has the designation Aztec C71, was initially discovered almost 10 years ago by a ground-based telescope, However, when the more advanced Hubble Space Telescope examined it, it vanished. With the help of the James Webb Space Telescope, the long-lurking world has now made a victorious return. The world ASX C71 looks like it's screaming into the void in an artist's representation, which gives the appearance that it has two eyes and a vast mouth. Its finding changes how scientists view the early universe and raises the possibility that immense star nurseries were 3 to 6 times more common than previously thought. That, according to the team's calculations, the redshift of the galaxy being observed is roughly 6, which places it at approximately 9 or 900 million years post-Big Bang. A real monster, this thing, the little mass, is actually responsible for the birth of many stars yearly. Despite appearances, what actually excites us is that our newest telescope produces images that are so sensitive that even something so dramatic is barely visible. An enormous number of galaxies may be revealing themselves to us thus, since dust absorbs most of the starlight and re-radiates it at redder, longer frequencies. Dusty worlds have proven challenging to photograph prior to this. Our only way of observing galaxies in the early universe had gone through the optical lens of the Hubble Space Telescope. Since our eyes are limited to the clear, dust-free worlds, our knowledge of galaxy evolution is skewed. However, the Hubble Space Telescope can't detect infrared characteristics that the NASA James Webb Space Telescope can. Since JWST is sensitive enough to look into the universe's farthest corners and penetrate even the thickest dust shroud, it will allow us to examine the optical and infrared characteristics of this previously hidden group of galaxies in an effort to early explore the universe's features. The Universe Web Project plans to map up to 1 million galaxies from an area of the sky the size of 3 full moons. Despite the observatory's reputation for staring into space at the farthest possible distance, NASA has also used its refined senses to make discoveries in our own backyard, using the detailed photos of Mars that Webb acquired. Last year, scientists will be able to examine more transient peculiarities like dust storms, weather conditions, and seasonal shifts. Yet, the red planet is a problem for the robust space telescope since the infrared light from Mars is blinding the instruments on board. Due to the extremely light conditions, astronomers had to use specialized data analysis techniques and use extremely brief exposures to correct. The researchers who made these discoveries claim they would analyze the spectroscopic and imaging data to look for